Now dear student, we are going to discuss question number 3.15, and in this question it is given to you instantaneous speed is always equal to magnitude of instantaneous velocity. Why? Actually we can write like this: average speed, we can write like this is limit delta t tending to 0 and this is delta x over delta t. Clear to everyone? So when we can say when delta t is equal to 0, it means this is a very small interval we have. So we can say at the time, if we calculate here average velocity, this is also written like this: limit delta t tending to 0. Here we will find this is displacement over delta t. So whenever we are talking about a very small interval delta t time, here you will not find any difference in a direction. Yes or no? So we can actually say in a small duration we will not find we do not find any difference between distance and the displacement. Yes or no? That's why we can say for a very small interval instantaneous. Instantaneous means what? At a particular time, or you can say delta t is tending to 0. So at a particular time we can say magnitude of instantaneous velocity and speed, this is equal. Yes or no? So this is all about this question. Now dear student, we are going to discuss question number 3.16, and in this question it is given to you: look at the graph from figure A to D carefully and state region which of the following cannot possibly represent one dimensional motion of a particle. Clear? So my dear student, we are going to analyze each and every graph and let us try to understand which graph is possible or which one is not. Clear? So now concentrate on a screen. Now in the situation number A, it is given to you. Let's suppose this is a graph that is given. Let's suppose if I draw here a perpendicular that is parallel to x-axis like this. Listen carefully what I want to say. You can see at a particular time, let's suppose this time is t. So at a particular time we are getting here two positions of a particle, this one and this one. I think you are getting my point. Yes or no? So at a particular time we are getting two positions of a particle, that is not possible. It means, let's suppose if I say to you, you are present at this time, you are attending this lecture, yes, and you are also eating some food that is somewhere else, then this is not possible, because whenever we have a one particle at the same time, a particle cannot be present at two positions. Clear? So it means we can say this does not represent motion in a straight line. Yes or no? So this graph will not represent one dimensional motion. Clear? Now if we move to the graph number B, in this graph we can say, let's suppose again if I draw a perpendicular, this is parallel to this velocity axis. We can see at a particular time, we are actually getting here two velocities. Clear? One velocity is positive, here we are getting positive velocity, and this one is negative velocity. It means what I want to say, let's suppose I am saying to you at time t equal to 2 seconds, particle is moving in positive x direction, particle is also moving in negative x direction. This is not possible. Yes or no? Because at a particular time the particle will always move in a particular direction. Clear? It means we can say this is also not possible. Clear to you? Yes or no? Yes. Now if we consider graph number C, in this graph is given to you between speed and a time, and now you can observe here it is also given the speed is also negative. Now speed is what? It is distance covered by the time per unit time, distance covered per unit time. So when we know for a particle is in motion, distance is always positive. It means we always find speed is positive. It means negative speed is not possible. It means we can say this is not a graph that is representing one dimensional motion. Clear? Now if we consider part number D, here it is given total path length versus time. Clear? So now you can see whenever a particle is having one dimensional motion, it is given total path length. It means this is distance, total distance covered. Clear? Now we know whenever particle is in motion, distance is always added. Let's suppose at time t equal to 0 I am here. When I am moving like this, it means let's suppose I covered distance 1 centimeter or 1 meter. Clear? Let's suppose after some time I again covered here some distance. It means now distance is always added. Yes or no? It means we can say from this graph you can see with time the distance is increasing. Yes, that is correct. But here we can say with time distance is decreasing. So this is also not possible. Yes, if this graph represents displacement, it may be possible. Clear? But for the distance this is not possible. So we can say from A, B, C, D all are not possible with reference to one dimensional motion. Clear to everyone? Now dear student, we are going to discuss question number 3.17, and in this question it is given to you, figure shows the xt plot of one dimensional motion of a particle. Is it correct to say from the graph that the particle move in a straight line for t less than 0 and on a parabolic path t greater than 0? If not, suggest a suitable physical context for this graph. Now dear student, we can see in this question a graph is given to you. This is xt graph, and when t greater than 0 this graph is parabolic, and t less than 0 this is given, that is a x equal to 0. Yes or no? So actually we can say t greater than 0 the particle move in a parabolic path. So we can say this graph does not giving this information. Why? Because if we want to know that particle has parabolic trajectory, it means we should know about trajectory equation, and trajectory equation is the graph between y versus x. Clear? But here graph is given to you between x and t. Clear to you? So directly we can say actually this graph does not represent trajectory, does not represent trajectory. Clear to you? Yes or no? So it means we can say how can we will, so what context is that we can derive from this graph? Actually we can say, let's suppose if we are talking about a case, and let's suppose body is situated at a certain height. Clear? Let's suppose we are talking about, let's suppose x equal to 0 and at t equal to 0 this body is at a certain height. Clear? And let's suppose we are saying this body is freely falling. Freely falling means we can say here we have u equal to 0. Clear? Then if we talk about, let's suppose this height we have, this is h. Clear? So now we know if this ball is freely falling, it means we can apply here equation of motion, because this body is moving under the influence of gravity. Clear? So we can write like this, s equal to ut plus half of at square. Clear? Now if we are taking this as our reference, we can write this is equal to minus times of, let's suppose this is x. Clear? I am taking this is x, so this is minus x equal to, we can say this is 0 plus 1 by 2, we can say this is minus g, and we can say this is t square. Clear? So from here you can write like this, x equal to 1 by 2 gt square. Clear? Or directly you can say x is directly proportional to t square. It means we are getting a graph between x and t, and this is parabolic in nature. Clear to everyone? Yes or no? So we can actually conclude from this graph that this is a case of a free falling. Clear? So what will happen when we have t less than 0? So actually t less than 0 does not exist, or we can say at t equal to 0 the position of the particle is here, and before this time particle is here. Yes or no? It means we can say position of particle is not changing with time. Clear? So this we can conclude from this graph. Clear to everyone? Now dear student, we are going to discuss question number 3.18. This question is related to chore and police question, or we can say this question is related to police and thief. Clear? In this question we will utilize the concept of relative motion. So now we are going to discuss this question. Concentrate on a screen. A policeman moving on a highway with a speed of 30 km per hour fires a bullet at thief's car. Clear? So let's suppose if I draw here a diagram, I can draw diagram like this. Let's suppose this is a given situation. Let's suppose this is a ground. Clear? In this question given, a policeman moving with a highway at a speed of 30 km per hour. Clear? So let's suppose this is ground, or we can say highway, and let's suppose this is policeman. Clear? Let's suppose this is policeman. Clear? This policeman is moving with a speed of 30 km per hour. Clear? So in this question it is given to you, this is velocity of a police car with respect to ground, and we can say this is 30 km per hour. Yes or no? Clear? Okay. Actually I am writing here just magnitude. Clear? So this is velocity of a police car with respect to ground. Clear? Okay. It fires a bullet at a thief's car. So let's suppose here a policeman fires a bullet from this car. Clear? Let's suppose thief car is going here in this direction. This is thief car, clear? And in this question it is given a thief car is speeding away in a same direction with a speed of 192 km per hour. So we can say velocity of thief car with respect to ground, clear? So this is given to you 192 km per hour, clear? Whenever it is given velocity of a thief car, it means this is with reference to a ground, clear? So this is given to you, okay? If muzzle speed of a bullet, what is the meaning of muzzle speed, clear? Muzzle speed means we can say velocity of a bullet with respect to police van, yes or no? So we can say velocity of a bullet with respect to police van, this is given to you, and this value given 150 meter per second, 150 meter per second, clear? Okay. So what speed does the bullet hit the thief's car, clear? So it means our objective in this question is to calculate velocity of bullet with respect to thief car, clear? Our objective is this one, clear to everyone? So now we can write what speed does the bullet hit thief car, clear? Objective is clear to you. So now how we will solve this question? So always keep in mind what is your objective. Our objective in this question is to calculate velocity of bullet with respect to thief car. We can write like this: velocity of bullet with respect to ground minus velocity of thief with respect to ground, clear? Now you can say velocity of thief with respect to ground we know, clear? Now velocity of bullet with respect to ground we have to find, clear? So how can we find? Let's suppose we are giving this is equation number 1, clear? We can write like this: velocity of bullet with respect to police van, this is equal to, or we can say velocity of bullet with respect to ground minus velocity of police with respect to ground, clear? So from here we can write like this: velocity of bullet with respect to ground, this is equal to velocity of bullet with respect to police plus velocity of police with respect to ground, clear? So velocity of bullet with respect to police, clear? This is given to you 150 meter per second, and this bullet is going in this direction. So we are assuming this direction as positive x-axis, clear? This direction is positive x-axis, clear? So we can write like this: this is equal to 150 meter per second. So this is 150 IK plus velocity of police with respect to ground 30 km per hour in right direction. So we can say this is 30 into 5 by 18, and this is IK, yes or no? First we convert this kilometer per hour in meter per second, clear? Now our objective, now we will put this value of velocity of bullet with respect to ground in this equation number 1, clear? So how can we write? We can write like this: velocity of bullet with respect to thief car, this is given by velocity of bullet with respect to ground. We can write this is 150 IK plus 30 into 5 by 18 IK, clear? This is given, this is IK, clear? Now velocity of thief with respect to ground, we know this is 192 km per hour. So we can say this is minus 192 into 5 by 18, and we can write also like this is IK, because thief is also going in the same direction, clear? So from here we can say we can easily calculate velocity of bullet with respect to thief car. What is meaning? Meaning is very simple: when this bullet embedded in this thief car, what is the speed, clear? So now we can say velocity of bullet with respect to thief, this is given by, we can say 150 IK plus, clear? If we take here common 5 by 18, clear? This is IK. So now we can write like this: this is 30 minus 192, clear to you? So this is equal to 150 IK plus 5 by 18 IK, and we can say this is minus 162, clear to you? So we can say this is equal to 8, clear? So we can write like this: 150 IK minus, we can say this is 40, yes, we can say this is 8, no, we can say 18, we can say this is what, 9, yes, 9 times, clear? So from here we can write this is 45 IK, yes or no? So from here we can say 150 minus 45, this is equal to 105 IK, clear? So actually we are getting here velocity of bullet with respect to thief. Clear? Thief means velocity of bullet with respect to thief car. Clear? Here magnitude is what? 105 meter per second. And what is direction? Direction is the direction that we assumed here. It means along the positive x direction. Clear to you? So this is all about this question. So what is our objective in this question? Is to calculate speed with which the bullet hit the thief car. So speed is what? It is the magnitude of a velocity. So we can write our answer. Answer of this question, we have velocity of bullet with respect to thief car. This is, we can see, magnitude of velocity. This is 105 meter per second. So this is correct answer. Clear to everyone? Now dear student, we are going to discuss question number 3.19, and in this question it is given to you, suggest a suitable physical situation for each of the following graphs. Clear? So first we are going to concentrate on graph number A. Now concentrate. So now we have to actually find that this graph number A is representing which situation. Clear? So let's suppose if I am saying, let's suppose here we have a wall. Let's suppose this is a wall, and let's suppose here we also have one wall. This is wall. Clear? And we have here also wall. Clear? Yes. Now let's suppose at any position we have here, let's suppose this is a football. This is football. Now let us try to understand. Let's suppose this is initial position of a football. Let's suppose I am saying this is x equal to 0. I am taking this direction is positive x axis. Clear? So now you can say, if I write here, let's suppose this is P, and let's suppose we can say this is T. Clear? Or let's suppose if I am saying this graph is representing what? This graph is representing the position of this football is not changing with time. Position of a football is not changing with time. It means we can say here this football is at rest. Clear to everyone? Now let's suppose a person kick this football in a right direction. Clear? So definitely we know now its speed will increase. Yes or no? So we can say this slope represent here, actually we can say this is xt graph, and the slope of xt graph represent this is velocity, or we can say magnitude, this is speed. Yes or no? So we can say here we are having a positive slope. Positive slope means what? We are having positive velocity. Clear? Because we can say this football is initially moving in this direction, so its speed increases first. After some time, what will happen? After some time, when this football hit this wall, again it will move in an opposite direction. Yes or no? But now it will move in with a reduced speed. Clear? And it move reduced speed, and finally again it come to the same position. Clear? Because here we are also getting x equal to 0. But what will happen? After that, after reaching this position, this football is now moving in a left direction. Clear? That's why we can say here we are getting negative displacement. Yes or no? And when it strike to this wall, when this football strike to this wall, at that time we can say it stick to this wall. Clear? Or we can say it comes to a rest. Yes. So now we can say this is the situation that is shown to you in a graph number A. Clear to everyone? Yes or no? Yes. Now listen. Now if we talk about situation number B, so this situation number B represent what? Let's suppose if we talk about motion under gravity. So let's suppose we have a ball, we are throwing a ball in a vertical upward direction. We know if we are providing some initial velocity, after some time we can say with the time speed, or we can say velocity of that ball decreases. Clear? At the maximum height we find velocity 0. Clear? So now you can see from this graph, if we talk from this point, so you can see here speed velocity that is decreasing with the time. Clear? It means we are throwing a ball in a vertical upward direction, and if you write here equation of motion, you can write like this: v equal to u plus at. Clear? We can write in a terms of time like this: v minus gt, because we are throwing a ball in a vertical upward direction and acceleration due to gravity act in a downward direction. Clear to you? So we can say here we are getting negative slope. Clear? So you can say this is negative slope. But what will happen when this ball, after that what will happen? At one point where we can say when ball reaches to the maximum height, its speed becomes 0. So this is that position. and after that this is again coming in a downward direction. Now it means we can say its speed is increases but direction of a velocity is different. Clear? When this ball strike to the ground, after striking to the ground, some energy of that ball is lost and now it will move in an upward direction with some reduced speed. Clear? And we can see now again direction of that ball changes, yes or no, and again we can see again velocity decreases up to the maximum height, again ball is going in a downward direction, again collide with the ground and again move in an upward direction with reduced speed. So we can say like this, after some time its energy is completely lost and finally it will come to rest. Clear to everyone? So this is a situation that is related to graph number B. Clear to everyone? Yes. Now if we concentrate on graph C, this graph is actually given to you between acceleration and the time, and whenever there is some change in an acceleration, it means we will find jerk. Clear? So what is this situation? Actually we can assume, let's suppose I have a cricket bowler, I am throwing a ball in this direction. Clear? Ball is going, let's suppose, with some uniform acceleration, but when it comes to the batsman, a batsman hit that ball and there is a sudden change in an acceleration we find. So whenever there is a sudden change in an acceleration within a short interval of time, we can see that is jerk. Yes. So after hitting by the batsman, what will happen? We can see again after some time ball will move with some constant acceleration, or we can say here the acceleration is 0. It means ball is moving with uniform speed. Clear? Here initially ball is moving in a uniform speed. Clear? Again I am explaining to you. Let's suppose if I am throwing a ball with uniform speed, when batsman hits that ball, at the time its acceleration sudden increases, and after hitting ball again come to uniform motion. So this graph is representing this situation. Clear to everyone? So I think you got all the clarity that which situation these three graphs is representing to you. Clear to everyone? Now dear student, we are going to discuss question number 3.20. In this question it is given to you, figure gives the xt plot of a particle executing one-dimensional simple harmonic motion. Give the sign of position, velocity and acceleration variables of a particle at time t equal to 0.3 second, 1.2 second and minus 1.2 second. Clear to you? So now concentrate. First let us try to understand here the given situation is for simple harmonic motion. Clear? Actually we have a chapter that is oscillation, chapter number 14 in part number 2nd of class 11. So in the oscillation we will find there is a relation between acceleration and the displacement, and that is given by A equal to minus times of omega square x. Clear to everyone? So now if we discuss situation number 1, when particle is at t equal to 0.3 second. When particle is at t equal to 0.3 second, it means we can see t equal to 0.3 second. It means this position is what? 0.5 second. Clear? So what is exact situation of particle A or particle at 0.3 second? So we can say this is actual position of a particle. Yes or no? Now you can say at this position, tell me value of x is positive or negative. Definitely we can say here we are getting negative value of x. Clear? So we can say for this situation we have x less than 0. Clear? Now we know because this is a xt graph. So if we draw a slope on at any point, then we can say this represent what? This represent velocity. Yes or no? This represent velocity. So now we can say this slope, again we can say this is a negative slope. Clear? So it means we can say velocity is also less than 0. Yes or no? Okay. Because our objective in this question is just to know what is sign of position, velocity and acceleration. Clear? Now we can say when we have x less than 0, then we can say A. It means acceleration. Acceleration is what? When x less than 0, we can say the acceleration is greater than 0. Clear? Yes or no? So this is for situation number first. Clear? Now we are going to discuss second situation. Let's suppose now if we talk about t equal to 1.2 second. Clear? So where we have 1.2 second, this is 1 and approximately we have this position. Clear? It means particle is here. This is 1.2 seconds. So particle is here. Clear? Okay, tell me what about the value of x? Definitely you can see from graph this x is greater than 0. Yes or no? X is greater than 0. What about velocity? If we draw here a tangent, definitely we can say we are having a positive slope. Slope means what? We can find here this theta, and this theta is acute, we can say acute angle, or we can say less than 90. So we will find it positive. So we can say velocity this is greater than 0. Clear? And what about acceleration? Clear? What about acceleration? So when we have x greater than 0, it means we can say acceleration we are getting less than 0. Clear? Because here we have negative value. Clear to everyone? Yes or no? Yes. Clear? Okay. Now if we discuss about next position, t equal to minus 1.2 second. Clear? So now if I write t equal to minus 1.2 second. Clear? Where we have minus 1.2 second, this position. Clear? This is minus 1.2 second. So we can say we have this position. Clear to you? So when we have this position, clear, this is minus 1.2 second. So again we can say here we are getting x less than 0. So we can say value of x less than 0. If we talk about velocity, clear? So if we draw here a tangent, definitely we are getting a positive slope. So velocity is greater than 0. And what about acceleration? When we put value x less than 0, it means this is negative. So we can say acceleration is greater than 0. Clear? So like this we can find here sign of x, v and acceleration. Clear to everyone? Now dear student, we are going to discuss this question, and this question is 3.21. In this question it is given to you, a xt graph is given to you, and for one dimensional motion 3 different equal time intervals, 1, 2, 3, all are having same equal intervals. This is shown to you. Now we have to find where we will find average speed is more, and we can say the greatest, and where is the average speed is least. Clear to everyone? So now we know, because here we have xt graph, so position time graph we have, and if we find slope of this xt curve, it will provide us we can say speed. Clear? Actually in velocity we will also take care about sign also, but in the speed we will only concern about magnitudes. Clear? So now we can see, if you talk about let's suppose if you take here slope, let's suppose if you take at slope, you will find in 1 and 2. Clear? And let's suppose if you take slope at any point on 3, so definitely we can say slope is greatest in the part number 3, or we can say in this interval 3. Clear? And it is having least in number 1. Clear? So directly you can see V average is greatest. V average is greatest for 3. Clear? And we can say this V average is least for number 1. Clear? So we are having average speed greatest for 3 and least for number 1. Clear? Now we have to find, give the sign of average velocity. Clear? So in average velocity you can say here we have x positive, here we have x positive, but here we are getting x negative. Clear? Or you can also find like this. This is given by, we can say x final minus x initial over t final minus t initial. Clear? Because we can say this delta t is same for everyone. Clear? So we can say for third number you can say this x final is less than compared to x initial. Clear? So definitely we will find here this average velocity this less than 0. Clear? So we can say average velocity is positive for 1 and 2, and average velocity is negative for number 3. Clear to everyone? So this is all about this question. Now dear student, we are going to discuss question number 3.22, and in this question it is given to you a figure provided to you. This is a speed time graph and of a particle motion along a constant direction. It means we can say motion along a straight line. Now 3 equal time interval, this is shown to you 1, 2 and 3. Okay, fine. In which interval is average acceleration is greatest in a magnitude. Clear? So now dear student, you know what is average acceleration? What is average acceleration? We can say this is defined as change in velocity change in velocity over, we can say this is change in time. Change in velocity and this is change in time. Clear? So now we can say equal time interval is given in all the situation, then we can say this average acceleration, it depends only on the change in velocity. Change in velocity. Clear? So we can say now we have to find in which situation we have more change in velocity. Clear? So if you concentrate on one, we have this much amount of change. Clear? In we can say change in speed, we have this one. Clear? Yes. And if we talk about interval number 2, here we have change in speed like this one. Clear? And if we discuss this one, almost we have a negligible change in speed. Clear? So from here you can say we will find maximum change in speed in interval number 2. Clear? So I think part A is clear to you. Yes or no? So correct answer for part A, or we can say A average is maximum, or we can say greatest in interval 2. Clear to you? Now next question we have, in which interval is average speed is greatest. Clear? So now our objective here is to calculate average speed. Clear? So now we can say here this is speed time graph is given to you, and average speed we have to find. So definitely directly we can see here, if we take here about the graph, definitely we are having these points is greater compared to other one. Clear? So definitely we will find average speed is greatest in interval number 3. Clear? So we can say V average is greatest in interval number 3. Clear to everyone? Yes. So 2 questions are completed, this one and this one. Now next one, it is given to you. Now choose positive direction as a constant direction of a motion. Give the sign of V and A in 3 intervals. Clear? So now we can say if we talk about V, so we can say V is positive in all the intervals. Clear? So I can write like this, V is always positive here. Clear? But what about acceleration? Because this is a VT graph is given to you, and if we want to find acceleration, we have to find slope. So in the interval number 1, we can say here we have positive slope. Clear? Here we can say we have a negative slope, and this one is also positive slope. Clear? So we can say acceleration is positive. So acceleration is positive for 1, 3 interval. Clear? Acceleration is positive for 1, 3 interval, and it is negative for second interval. Clear to everyone? Yes or no? Yes. Now last part we have what are the acceleration at point A, B, C and D. Clear? Now let's suppose, concentrate on a screen. Let's suppose if I say this is a point A, this is a point B, this is C and this is D. Now we can say if we draw here a tangent, it will be that is parallel to time axis like this. Yes or no? So we can say whenever we have slope 0 and slope of VT graph represent acceleration, it means we can say acceleration at point A, B, C and D, this is 0. So we can say acceleration is 0 at A, B, C, D. Clear to everyone? Yes. So this is all about this question. Now dear student, we are going to discuss question number 3.23, and in this question it is given to you, 3 wheelers start from rest. Okay, it means initial velocity is given to you, this is 0. Initial velocity we have 0. Accelerate uniformly with acceleration 1 meter per second square. So this is 1 meter per second square, and on a straight road for 10 seconds. So value of t, this is given 10 seconds. Clear? Then it move with uniform velocity. Fine. Plot the distance covered by the vehicle during nth second. Okay. And what do you expect to be plot this acceleration motion, it is a straight line or a parabola. Clear? So now concentrate on a screen. Actually here we will draw a graph. This is between x and t. It is given to you. Yes, we have to plot here a graph between distance covered and the with the time. So distance covered by the vehicle during nth second versus n. Clear? So now we can write like this. We can say this is distance covered in an nth second and with n. Clear? We can put here value of n. Let's suppose this is 0. Here we have 1, 2, 3, 4, 5, 6, 7, 8, and we can write like this. This is 9, 10, 11 and so on. Clear? We can write up to 12. This is 12. Clear to you? Yes or no? Now, if we say here, our objective here is to calculate ascent. It means distance covered by three-wheeler in nth second. Clear to everyone? So now we can write like this. As nth, we know formula. What do you know formula? Yes, this is u plus a by 2 twice n minus 1. This three-wheeler is starting from rest. It means initial velocity we have 0. Acceleration is given 1. So we can write like this 1 by 2 2n minus 1. Clear? So directly we can say ascent. This is given by 1 by 2 2n minus 1. Clear to you? Yes or no? So ascent is equal to what? 1 by 2 2n minus 1. Clear? So this one. Now we will draw here a table, and after the table we will draw here a graph. Clear? Actually it is given in a question. It is moving, accelerating uniformly for 10 seconds. Clear? And after that it is going with a uniform velocity. Clear? So for the 10 second, can we draw here a graph? So first we are actually drawing here a table. So listen carefully. So let's suppose if I draw here a table like this, we can say this is what? We can say this is ascent distance covered, and we have here 1. Clear? So if we put value of n equal to 1. Clear? So if we put n equal to 1, we have here 1 by 2, this is 0.5. If we put value 2, clear? We can say 2 multiply 2, 4 minus 1, 3 by 2, this is 1.5. If we put here value 3, clear? If we put 3, we have 5 divided by 2, 2.5. If we have 4 means 2 multiply 4, 8 minus 1, 7, this is 3.5. If we have 5, clear? We have 9, so we can say 4.5. If we have 6, clear? We can say 11, so this is 5.5. If we have 7, clear? We can say 13 by 2, this is 6.5. If we have 8, clear? We can say 16 or we can say 15, so this is 7.5. If we have 9, we can say 17 by 2, it means 8.5. Clear? And if we put here 10, then we can say 19, so we can say 9.5. Clear? So now if we plot here a graph, we can plot like this for n equal to 1. Clear? I am taking here, let's suppose this is 0.5, clear? 1.5, this is 2.5, 3.5, 4.5, clear? 5.5, 6.5, then we can write like this 6.5, 7.5, 8.5, 9.5. Clear? So now in this question it is given to you for n equal to 1, 0.5. So here we have, clear? Then we can say at n equal to 2, 1.5, it means this one. Then we have this graph. Clear? We can say we have this much of graph. Yes or no? Clear to you? Now 4, 5, we can say this is 4.5. Yes or no? 4, 5 we have 4.5. 6 we can say 5.5. You can take here a suitable scale. Clear? Clear? So now listen carefully. Now if we join all the dots, it will be look like this up to 10. Clear to you? Up to 10. This one. clear. But what will happen after 10 seconds? After 10 seconds, this three-wheeler is going with uniform velocity. It means we can see after 10 seconds, its position is not changing with the time, clear. Or uniform velocity means we can say equal change in position we have for equal interval of time. So we can say it will be like this. Or we can say slope of xt graph, it will be 0, yes or no? Yes or no? So we can say this is a graph between, we can say distance covered in nth second versus we can say n. Clear to everyone? So what do you expect from this plot? So we can say from 0 to directly we can say up to we can say for n equal to 1 to n equal to 10, we have here a straight line, and after that we have a line or a graph, this is parallel to n. Clear to everyone? So this is all about this question. But important, this will not pass through 0, always keep in mind. Clear? This will not passes through 0. Clear to everyone? So now dear student, you know here we have at 10 n equal to 10, we have nth value, this is 9.5. Clear? And after n, we can see after this 10, clear, it is given that after 10 seconds we can say it is moving with uniform velocity. So can we find here velocity of a three-wheeler after 10 seconds? Yes. So we can write like this. Actually we know v equal to u plus at. Clear? V equal to u plus at. So we can say v equal to, initial we have 0, this is what, 9.8 multiply t. So or we can say acceleration is given, this is 1, clear, and time this is 10, clear. So we can say this is 10 meter per second. So we can say at n equal to 10, clear, we can say this is 10 meter per second. Clear to everyone? So this is all about this question. Now dear student, we are going to discuss question number 3.24, and in this question it is given to you, a boy standing on a stationary lift open from above throws a ball upward with the maximum initial speed he can equal to 49 meter per second. So situation is given to you like this. Let's suppose we have, this is a lift, clear, and this is an open lift, and at this time this is stationary. So we can say this is stationary, clear. Let's suppose here we have a boy, let's suppose this is a boy, and this boy is actually throwing a ball in a vertical upward direction, and this is given to you 49 meter per second. This is given, clear. So u equal to 49 meter per second, this is given to us. Okay. So our objective here, in how much time this ball take to return to his hand, clear. So when lift is stationary, so if we consider first case, when lift is stationary, clear. First we will find here total time taken by this ball to reach up to maximum height. So we can write like this, v equal to u plus at. Now we know at maximum height we have final velocity 0, clear. We are taking upward direction positive, so this is 49. We know acceleration due to gravity always act in downward direction, vertically downward, and it is multiplied with, let's suppose, time t1, clear. So t1 time, this is given by 49 divided by 9.8, clear. From here we can say 49 divided by 98 into 10, clear. So now we can say this is equal to 2. So t1 equal to, directly we can say this is 5 seconds, clear. Now if we are ignoring here ignoring air, we can say air drag, or if we are assuming here that viscous force is not present, air drag is not present, at that time we know time of ascent is equal to time of descent, clear. So time of ascent means we can say t1, this is equal to t2, clear. Time of ascent equal to time of descent. So total time taken by the ball to reach up to maximum height and again coming to ground, it means we can see total time taken, we can calculate like this, t equal to t1 plus t2, clear. So t1 plus t2, we can say this is equal to twice of t1, and this is given by 2 into 5, so we can say this is 10 of second, clear. So we can say this t is given, that is 10 second, clear to everyone. So now we can say boy again catches that ball, this is we can say in a 10 second. Clear everyone? Now situation changes. If the lift start moving up with a uniform speed 5 meter per second. Now let's suppose this lift is now not as stationary, this is also moving with a speed 5 meter per second. Clear? Now we have to find that how long does the ball take to return to his hand. Clear? Now important part. Now you can see lift is moving in a vertical upward direction. Yes, it means the person or this boy is also inside the lift. So this boy is also moving with the same speed as this lift. Yes or no? It means this ball is also having that speed. Yes or no? So it means we can say the velocity of that ball with respect to this boy is not changing. Clear? Or you can also understand this concept with the help of inertial or non-inertial frames. Clear? So whenever we are observing motion of this ball from a ground reference, we can say this is inertial frame, and if we are observing motion of this ball in an accelerating frame, then we can say this is non-inertial frame. Clear? So we can say time taken will be same, this is 10 seconds. Clear? And if we apply here concept of non-inertial frame, we can see net force. If we write net force equal to mass into acceleration, because this lift is going in upward direction with uniform speed, so acceleration is 0. So we can say there is no any pseudo force will act. Clear? So this concept you will learn in a law of, we can say laws of motion. In laws of motion you will understand the concept of inertial and non-inertial frame. Clear? So we can say total time taken by the ball to reach again hand of a boy, this is 10 seconds. Clear to everyone? So this is solution of this question. Now dear student, we are going to discuss question number 3.25, and in this question it is given to you on a long horizontal moving belt as shown in a figure. A child runs to and fro with a speed 9 km per hour with respect to a belt. Clear? So here it is given to you velocity of a child. Velocity of a child is given to you. So velocity of a child with respect to belt, this is given to you, and this is 9 km per hour. Okay. Between his father and mother, and distance between father and mother is given to you 50 meter. Clear? Let's suppose we have an observer, and this observer is observing from outside. Clear? Now our objective here is to solve these questions. Clear? So now concentrate. Now it is given in this question, what is speed of a child running in a speed of child running in direction of motion of a belt. Clear? So we can write like this, velocity of a child with respect to belt, this is given by velocity of child with respect to ground minus velocity of belt with respect to ground. Velocity of belt with respect to ground. Our objective in this question in part number A, to find the speed of a child running in direction of motion. So speed of child with respect to ground, this is written velocity of child with respect to B plus velocity of belt with respect to ground. Now child is actually running in the direction of a belt. Clear? It means we can see, let's suppose we are assuming this direction is positive x-axis, so we can write like this, velocity of child with respect to belt. Clear? So you can also take like this, let's suppose we are taking this direction positive. Clear? No need to write here vector. So velocity of child with respect to B, it means velocity of child with respect to belt, this is 9 plus velocity of belt with respect to ground, we have 4. So total we can say this is 13 km per hour. Clear to you? Now in part number B, question is asking to you, if a child is running in opposite direction of motion of a belt, then we can write this velocity of a child with respect to belt, because now child is moving in this direction, so we can take it negative. Clear? So we can write here this is minus 9. Clear to you? And we have velocity of belt with respect to ground, this is 4, because this is moving in a positive direction. Clear? So we can say here we will get this is minus 5 km per hour. This minus 5 indicate what? An observer that is stationary. Clear? He is observing the person, or we can say the child is moving in a left direction. Clear to you? So we can see here velocity of a child with respect to ground, we have 5 km per hour. Clear to you? So A and B is completed. What is time taken by child in A and B? Now actually the observer is outside. Let's suppose if we place this observer on the bed itself, or if we talk about non-inertial frame. So in the concept of a non-inertial frame, can we find here the time? Yes, directly we can calculate here time. So how we will calculate? Now we can write like this: time taken is given, time taken by the child. So time taken by the child is what? Because distance between father and mother we have 50 meter, so we can say total distance we have 50 divided by. Now when observer itself is on belt, then he find the child is moving with 9 km per hour. So we can say this is 9. So we can write like this: this is 20, we can say 50 by 9, and this is 50. 50 is given to you in a meter. So we can write like this: this is 5 by 80. Clear to you? So we can say this is 2, this is 10. So total we can say we have time taken 20 seconds. Yes or no? Now important part: which of the answer alter if motion is observed by the parents? Clear? So actually only we can say the time taken by the child to reach from father to mother, that will not change. Only thing that it changes, that is speed of a child running. Yes or no? If you are observing speed of a child from the reference of a ground, you will find here speed that is 13 km per hour or 5 km per hour. Clear? But if you are observing from parents' point of view, you can see this is 9 km per hour. Clear? So only the speed of a child this is changing, but the time this is not changing. Clear to everyone? So this is all about this question. So now dear student, we are going to discuss question number 3.26. In this question it is given to you: two stones are thrown up simultaneously from edge of a cliff 200 meter high with initial speed of 15 meter per second and 30 meter per second. Verify that the graph shown in a figure correctly represents time variation of a relative position of second stone with respect to first. Clear? We have to neglect here air resistance and assume that stone do not rebound after hitting the ground. Clear? So this question is given to you. Now let us try to solve this question. Clear? So concentrate on a screen. Now listen carefully. In this question it is given to you: two stones are thrown simultaneously from edge of a cliff. So let's suppose we are taking here reference. Let's suppose this is a reference. Clear? Let's suppose this is ground. Clear? Let's suppose here we have a cliff. Let's suppose this one. Clear? And actually we are throwing two objects simultaneously in vertically upward direction. So we can see here we have, let's suppose u1, this is 15 meter per second, this is given in a question, and we have another object having initial velocity 30 meter per second, this is given to you. Clear? So now we are throwing this two balls simultaneously in vertical upward direction. Fine. Now we have to verify that the graph this is shown in a figure, this is correct or not. Yes or no? So now listen carefully. Now let's suppose I am taking this ground as an origin. Clear? And height of this cliff is given to you 200 meter. Clear? So let's suppose if we discuss about position of two different particles after time t. So how can we write? I can write like this: x1. x1 means what? Position of a particle after time t. Clear? So we can write like this: x1, this is equal to what? 200 plus, because we are taking reference this ground, so 200 plus. Now you can say whenever we are throwing an object in vertical upward direction, it will move under the influence of gravity, and we can say constant acceleration will act on that body. It means we can apply equation of motion. So from here you can say initial speed we have 15, so ut plus half of at square, so we can say 15t plus 1 by 2. Now listen carefully. If we are taking vertical upward direction positive, we can say this is minus g and this is t square. Yes or no? So from here we can write like this: x1, this is equal to 200 plus 15t minus, if we are taking value of g, this is 10, so we can write like this: this is 5t square. clear. Similarly, we can write for particle number second also. So we can write like this, x2, this is equal to, we can say again we have 200 plus initial velocity in upward direction, this is 30t minus half of gt square, clear. From here we can say x2 value is given 200 plus 30t minus 5t square, clear to you, yes or no. So we can say here we are having two equations, this is for x1 and this one is for x2, clear to you, yes or no. So now I am rubbing all these things and I am just writing here value x1 and x2. So x1 we have 200 plus 15t, I am writing here x1, this is equal to 200 plus 15t minus 5t square, clear. And I am writing here x2 also. So value of x2, this is given by 200 plus 30t minus this is 5t square, clear to you. Now first we will try to find that at what time body 1 and or we can say this stone, at what time stone number 1 or stone number 2 it hit to the ground, clear. So we can say if we are taking reference to this ground, clear. So first I am finding here when x1 will be 0, yes or no. So when we will put like this, we can write like this 200 plus 15t minus 5t square, this should be equal to 0, clear. And we can also write like this t square minus 3t minus 40, this should be equal to 0, yes or no. T square positive, this is minus 3t, this is also minus, and we can say this is 40, clear. So how can we write here, because this is 40, so we can write like this t square minus 8t plus 5t minus 40, this should be equal to 0, clear. From here we can write like this t minus 8 plus 5 t minus 8, this should be equal to 0, clear. So from here we can say t minus 8 and this is t plus 5, this should be equal to 0, clear. So from here we can say t value we have, this is equal to 8 and t not equal to minus 5, clear. So it means we can say actually t equal to minus 5, but we know time is always positive, so we will not take it into consideration, clear. So it means we can say particle or we can say stone number 1, it will come to rest or it will come to ground at time t equal to 8 seconds, clear to you, yes or no. So I am writing here, clear. So from here we can say that this particle come to rest at t1 equal to, or let's suppose t equal to 8 seconds, clear to you. Now let us try to find which stone will come to rest first, clear. So we can say, we can assume it is particle or stone, but if we talk about stone, let us try to find the time in which this stone is coming to the ground, stone number 2, clear. So we can write like this 200 plus 30t minus 5t square, this should be equal to 0. From here you can write like this t square minus 6t minus 40, this should be equal to 0, clear. From here we can say this is 10t plus 40 minus 40, this should be equal to 0, clear. So if we take here t common, t minus 10 plus 4 t minus 10, this should be equal to 0, clear. So we can say t minus 10 t plus 4, this should be equal to 0, clear. So we can write like this, this is equal to 10 minus 4. So definitely we can say time we will not take negative. So here we can say time we have, this is 10 seconds. So small t we can say this is 10 seconds, clear to you. So now we can say this particle come to rest at 10 seconds, yes or no, clear to you, yes. So now you can say if we compare stone number 1 and stone number 2, clear, which stone first come to rest or which stone first come to ground. So we can say stone number 1, clear. So if we find here, because we have to draw here a graph between x2 minus x1 and time, clear. So we can write like this, if we do here x2 minus x1, clear, we can say 200 cancel, 30t minus 15t, this is 15t and this one is also cancelled out. Clear? So from here you can say up to time from 0 to 8 second, 0 to 8 second, x2 minus x1, this is equal to 15t. Yes or no? So we can say from t equal to 0 to t equal to 8 second, we can say x2 minus x1 is directly proportional to t. Clear to everyone? Yes. Now what will happen after 8 second? We can say first stone come to rest, and what about second stone? So we can say only second stone will move with this equation. Follow this trajectory, 200 plus 30t minus 5t square. Clear to you? So this second number stone follow this trajectory. From here you can say x is actually varying according to minus t square. It means this is showing a parabolic path. Clear? Yes. So we can say this is showing a parabolic path, and stone number 2, it will also come to rest at t equal to 10 second. So at t equal to 10 second, stone 2 come to rest. Clear? And what will happen after 10 second? So we can write like this, x2 minus x1, because second stone also come to ground, x1 is already on the ground, so we can say this always come out to be 0. It means we can say x2 minus x1 now is not varying with time. That's why we can say here we are getting this constant and this graph. Clear? This is on x time axis. Yes or no? So it means we can say the graph that is given to you, this is perfectly correct according to given situation. Clear to everyone? Now dear student, we are going to solve question number 3.27. Clear? In this question it is given to you, the speed time graph of a particle moving along a fixed direction is shown in a figure. Obtain the distance traversed by the particle between t equal to 0 second to 10 second, or we can say between t equal to 2 second to 6 second, and we have to also find what is average speed of a particle over the intervals in A and B. Clear to you? Yes or no? So now we are going to discuss solution of this question. So concentrate. In the first case, actually we have to find distance covered by the particle between t equal to 0 second to 10 second. Clear? So now you can say from t equal to 0 second to t equal to 10 second, our objective here is to calculate distance. This graph is given to you for speed and the time graph. Clear? So we can say it means if we find here area under the curve, so area under the curve of VT graph, it provides you distance covered. If we have this speed, definitely it will provide to you distance. So can we find here area? Yes, 1 by 2 into. Now we can say what is this length, or 1 by 2 half in 1 by 2 into base into perpendicular height. Yes or no? So base is given to you, this is 10 minus 0. So we can write like this, 10 minus 0 into perpendicular height. So perpendicular height is given by, this is 12 meter per second. So we can say this is multiplied with 12. Clear? So from here we can say this is what, 6 into multiplied 10 minus 0. Clear? So from here we can say this is 60. Yes or no? So this 60 is what? We can say 60 meter. Clear? Because concept is what? Concept is here area under VT graph. It provides to you, this is distance covered. Clear? Distance covered. Clear to everyone? Now next objective here, what is average speed of the particle? Clear? So average speed we can find like this, we average, this is equal to total distance over total time. Clear? So total distance we can say we have, this is 60 meter. Yes or no? And total time, so we can say from 0 to 10 we have 10 second. So now we can write like this, this is 6 meter per second. Clear to you? So this is solution of part number A. Clear? Same we have to find between time t equal to 2 second to 6 second. Clear? So now concentrate. Now if we find t equal to 2 second to 6 second. Clear? Concentrate. Yes. Now we can say where is the t equal to 2 second? Let's suppose at this point. Clear? Here we have t equal to 2 second, and from t equal to 2 to t equal to 6 second. So we can say, let's suppose this is 6. Clear? So this is 6 second. Yes or no? Now Now we can say first our objective here is to calculate total distance covered. It means how can we find, let's suppose if I say this is A, this one is B, and let's suppose this is C. So total distance we can find if we add AB plus BC, means we can say distance covered between A and B and then B and C. Clear? So we can write like this. First we will find velocity at A. Clear? Initial speed of a particle, this is given 0. So we can say this is 0 plus A into T. Clear? So total time we can say A multiplied 2. Clear? How can we find acceleration? Because this is a VT graph. So if you find slope of this VT curve, we can easily find acceleration. Clear? So acceleration we can find like this. We can say this is y2 minus y1. Clear? So I can say this is 12 minus 0. Yes or no? Because here we have coordinate 5 comma 12 and this is 0 comma 0. Clear? So we can say 12 minus 0 divided by 5 minus 0. Clear? So from here we can say acceleration we have 12 by 5 meter per second square for O to B. Clear? Now we can write here. So velocity of a particle at position A, we can say 2 multiply 12 by 5. So this is 24 by 5, and from here we can say this is 4.8 meter per second. Clear? So now we know what is velocity of a particle at point A. Clear? Now we can calculate what is distance covered between A and B, because it is given here acceleration we have, this is constant. So whenever we have a constant acceleration, we can apply equation of motion. Clear? So now we can write like this, equation of motion. Clear? So we can apply equation of motion. Equation of motion means we can write like this, SAB means we can say distance covered between A and B, this is equal to initial velocity we have 4.8, clear, or multiplied with T. So from here 2 to 5 we have total 3 seconds. So this is 3 plus we can write like this, 1 by 2 half of AT square. A is given to you, this is 12 by 5 into T square means this one. Clear? From here you can say this is what we can say this is 14.4 plus we can say this is 6. So plus we can say here 9 multiply 6 by 5. Clear? So 14.4 plus we can say 54 by 4, this is 10.8. Clear? So from here you can say this is 25 by 2 meter. Clear? So total distance covered between A and B we have, this is 25.2 meter. Clear? Now can we find total distance covered between B and C? Yes. Again first we have to find slope. Yes or no? So B to C, I am writing here B to C. So B to C we can write like this, if we find acceleration. Clear? Because now you can say here we have a graph, this is speed is decreasing, or we can say here we will find retardation. Clear? If you are getting any confusion, you can write like this, this is what we can say y2 minus y1, let's suppose this is y2. So we can say y2 minus y1 over 5 minus 10. Clear? So you will get here negative acceleration, and this is 12 upon minus 5. Clear? So from here we can calculate distance covered by particle from B to C. Clear? So I can write like this. So from here we can say SBC. Now ut plus half of AT square, initial speed we have 12, so 12 T. T we can say from 5 to 6, so we can say this is 1 ut plus half of AT square. Clear? A is given to you minus 12 by 5 over T square means 1 square. Clear? From here you can say 12 minus 6 by 5. Clear? So from here you can say this is what 1.2, so we can say this is 10.8 meter. Clear? So from here we can say what is total distance covered from A to B and then B to C. So directly we can say total distance. So we can say total distance, this is equal to what? First we can say A to B. A to B have 25.2 plus B to C we have distance 10.8. Clear? So from here you can say this is 35 and this is 36 meter. So total distance covered we have 36 meter. Clear? Okay. So when we have total distance 36 meter, next our objective, first objective is completed, next objective is to calculate average speed. Average speed we have total distance upon total time. So 36 divided by total distance, total time we have. So we can say total time from 2 to 6, yes or no? 2 to 6 means we have 4 seconds. So we can say this is 9 meter per second. Clear? So like this you can calculate all the values. So this is all about solution of this question. Now dear student, we are going to discuss next question. This is 3.28 and last question of this chapter. In this question it is given to you, velocity time graph of a particle of a one dimensional motion is shown in a figure. It is given, which of the following formula are correct for the describing motion of a particle over the time t1 to t2. Clear? Now first let us try to analyze the graph. After that we will move on to the given parts. Clear? So here you can see graph between v and t is given to you. Clear? And we can say here the graph is not a straight line graph. Clear? It means we can say acceleration is not constant, acceleration is varying. You can also find like this. If you draw tangent at any point, let's suppose if you draw tangent at this point, let's suppose if you draw tangent at this point, clear, you can say value of slope you are getting, this is different at different point. Clear? It means we can say here we are having non-uniform acceleration. Clear? So definitely whenever we have non-uniform acceleration, we cannot apply equation of motion. Clear? So now here we have to find that which formula is correct or not according to given situation. Now let us try to see. If we talk about number A part we have xt2 means position of a particle at time t2. It is given to you xt1 plus vt2 minus t1 half of at square. So here what we are doing, actually we are applying displacement equal to ut plus half of at square, and we cannot apply it because particle is not having constant acceleration. It means we can say this this relationship that is given to you is not correct. This formula is not correct. Clear? Second formula, again we can say this is not correct because particle is having non-uniform acceleration. V average equal to x t2 minus x1 divided by t2 by t1. Yes, now you can write like this, because how can we define average velocity or average speed? It is defined as total distance covered upon total time. So we can write like this. Yes, this formula is correct. Alpha average, it is given to you v t2 minus v t1 upon t2 minus t1. Yes, because we know average acceleration is given by total change in velocity over total time. Clear? So we can say this is also correct. This formula is correct. Next formula, x t2 equal to x t1 v average t2 minus t1. Actually whenever we are writing equation of a motion, we will never utilize average speed. Clear? So you can say whenever we are using here average, this is also alpha average, we cannot write it. Clear? Because this is these equations are not for average value. These equations are for a specific constant value of acceleration, or we can say. Clear? So we can say this formula is also not correct. Clear? Last one, x t2 minus x t1, this is area under vt curve bounded by t axis and the dotted line. Exactly, because this is what vt curve. So if you find area under this vt graph, definitely you will find here displacement. Clear? If we have velocity, you will find displacement. It means we can say the last part, this is correct. Clear to you? So this is all about this question.